Hey everyone, and a very warm welcome back to the Pod4 Journal Club. I am absolutely pumped you're here today because we have a seriously mind-blowing explainer lined up for you. We're diving into a brand new, groundbreaking scientific paper about clinical artificial intelligence that is, honestly, fundamentally challenging everything we thought we knew about evaluating medical tech. If you love rigorous, deep dive breakdowns of the latest scientific literature without drowning in all that unnecessary jargon, well, you are in exactly the right place. Right off the bat, I want you to look at the massive gap between these two numbers, $29.50 versus 2 cents. This right here represents a massive paradigm-shifting cost drop that we're going to be unpacking today. How in the world did the cost of a crucial medical evaluation process plummet by nearly 1,000 times? We're going to find out. And hey, quick favor, if you enjoy this kind of data-driven, structured explainer, please take a quick second to hit that subscribe button using the link down in the description. It really helps the channel grow and make sure you never miss out on these kinds of insights. So the whole thing really boils down to this core research question. We all know AI is cheap, right? And it's incredibly fast. But can we actually trust an AI to grade its own clinical documentation just as well as an expert human doctor could? I mean, it's one thing to have an AI write a medical note, but asking an AI to evaluate that same note for accuracy and clinical safety, that is an entirely different frontier. Okay, let's map out exactly where we're headed. 1, the AI doctor note dilemma. 2, methodology, testing AI evaluators. 3, the shocking data and findings. 4, limitations and ceiling compression. And 5, real-world implications and future. Let's jump right into Section 1, the AI doctor note dilemma. To really grasp why this paper is such a game changer, we kind of have to start with the immense, crushing burden of documentation on modern doctors. It's a pretty well-known fact at this point that physicians spend a staggering chunk of their day just typing up notes instead of, actually looking at patients. To fix this, the medical field brought in something called ambient AI. If you haven't heard that term yet, ambient AI is basically just tech that securely listens to the natural, everyday conversation between a doctor and a patient in the background, and then it automatically drafts up the clinical documentation. It's like having an invisible, automated scribe in the room. Now, where do all these automated notes actually go? They go straight into the EHR, the electronic health record. That's just the digital version of a patient's entire medical chart. It's got your history, your diagnoses, your meds, the whole shebang. So as you can imagine, accuracy here is absolutely vital. If an AI hallucinates or makes a mistake in the EHR, that could have some really serious, real-world consequences for patient care. Which leads us straight into our dilemma, because accuracy is literally a matter of life and death. The ultimate gold standard for checking these AI-generated notes has always been having an expert human review them. But here is the massive bottleneck. Having a real, highly paid doctor review and grade every single AI output is painfully slow and wildly expensive. AI models update constantly, sometimes weekly, and human evaluators simply cannot scale up to keep pace with that kind of continuous, safe AI development. Moving on to Section 2, methodology, testing AI evaluators. This specific bottleneck is exactly what led researchers, spearheaded by Aryan Shah and his team, to design a frankly brilliant experiment. To understand how they tested these AI evaluators against human experts, we just need to define one quick concept: a rubric. Think back to high school for a second. A rubric is literally just a grading checklist with weighted criteria that a teacher uses to grade your essay. Only in this case, instead of an essay, we're grading a medical note. And the criteria are things like, is it clinically accurate? Did it capture the whole treatment plan? Did it hallucinate any weird facts? Now, take a look at the dual workflow mapped out here. It's super cool. On the left side, the researchers took 823 real-world and synthetic clinical encounters, and they had 20 human doctors manually review that patient data to author over 1,600 grading rubrics. Then, on the right side, they had a large language model, an LLM, do the exact same thing, automatically generating rubrics for those exact same 823 cases. After that, they used a system called Hyperscribe, which is an EHR-embedded clinical AI agent, to generate the actual medical notes. And they graded those notes using both the human rubrics and the AI rubrics. It's a complete parallel run. So as you can see, the process was perfectly mirrored. Step 1, input the exact same patient transcript and medical context. Step 2, have either the human doctor or the AI author a customized case-specific grading rubric. And step 3, use an automated scoring agent to grade the Hyperscribe notes based on those rubrics. It was basically a true head-to-head battle to see if the AI's grading rules actually aligned with the expert doctor's rules. All right, section 3, the shocking data and findings. I have to tell you, the results of this head-to-head matchup are absolutely fascinating. The data reveals a shift that could literally alter how all medical software is tested going forward. First off, let's validate that massive hook I threw at you at the start of the explainer. When the human doctors created these grading rubrics, it took a median of 18 minutes per case and cost roughly $29.50 in labor. When the LLM generated the rubric for the exact same case, it took seconds, and it cost exactly 2 cents. That is a cost reduction of 3 orders of magnitude. But of course, being dirt cheap doesn't matter at all if the AI is grading it incorrectly, right? And this brings us to the most shocking finding of the entire paper. The researchers used this statistical metric called a tau score. It measures inter-rater agreement, which is really just a fancy way of saying how often did 2 different graders agree on which AI note was the best. Notice those 2 green bars representing the tau score from their later experiments. The agreement between 2 human doctors was between 0.38 and 0.43, but the agreement between a human doctor and the LLM was 0.42 to 0.46. No way, right? The AI evaluator didn't just match the human agreement, it actually slightly exceeded the agreement between 2 independent human experts. Which takes us to section 4, limitations and ceiling compression. Now, look, as much as we absolutely love an incredible tech breakthrough here on the Journal Club, it's vital that we maintain our scientific rigor. We've got to ground this enthusiasm by looking at a really fascinating statistical quirk the researchers ran into. Check out this box plot. It shows the quality of the medical notes generated by the hyperscribe system across 7 different experimental updates. Over time, the AI system got really, really good. By the time they reached the later experiments on the right, the median score had jumped to about 95%, with this massive cluster of scores hitting a perfect 100%. The researchers call this phenomenon ceiling compression. Basically, when the AI starts outputting exceptionally high-quality notes across the board, trying to distinguish the absolute best note becomes incredibly difficult. Think about it like this. If you have a whole classroom of students who all get an A+ on their final essays, it becomes mathematically much harder for 2 different teachers to agree on who is the absolute #1 student in the class. This compression actually made it harder for the human doctors to agree with each other, which is partly why the AI was able to match and even beat their agreement rates. The authors are also super transparent about the limitations of their study, which we always appreciate. This data all comes from evaluating a single AI system, Hyperscribe, and it was embedded within a single platform, Canvas Medical. Furthermore, the rubrics were strictly evaluating documentation fidelity, meaning did the text accurately reflect the conversation. It did not assess deeper clinical reasoning, and it didn't look at long-term downstream patient outcomes. Those are some pretty big gaps that future research is definitely going to need to address. And finally, section 5, real-world implications and future. So bring this all together, what does this 1000x cost collapse actually mean for the future of healthcare tech? Well, the researchers propose what they call a hybrid evaluation model, and I think it's beautifully summarized right here in this table. Relying only on clinicians at nearly $30 a pop, it's just way too expensive to do at a daily, massive scale. But relying only on LLMs for 2 cents? Well, that's great for sheer volume, but it lacks that ultimate human expert ground truth that keeps everything safe. So the optimal future is clearly this blended model. We use dirt-cheap AI evaluators to test millions of notes at high volume, and then we use a smaller, targeted sample of human experts to spot-check things and ensure the AI evaluators stay anchored to clinical reality. I actually want to read you this powerful quote directly from the paper because it perfectly nails why this matters so much. They wrote, "At 3 orders of magnitude lower cost, LLM-generated rubrics enable evaluation coverage that would be economically infeasible with clinician authorship alone. In plain English, we can now safely and continuously test clinical AI systems at a massive scale that was previously completely impossible. And that means safer, faster, and much more reliable AI tools for both doctors and patients." Which leaves us with one final, pretty provocative question to ponder today. If AI can now accurately evaluate its own clinical outputs for literal pennies and match the agreement of seasoned expert doctors, what exactly does the future of human expertise look like in medical administration? It is a fascinating thought to leave you with. Thank you so much for hanging out with me today on this explainer. If you found this breakdown valuable, please remember to hit that subscribe button down in the description so you can catch more episodes of the Pod4 Journal Club. Stay curious, keep learning, and I'll see you next time.